Thank you, Naresh, for the lovely introduction. Hi, everyone. My name is Nikhil Barthwal, and I'll be talking about cloud native CI/CD for the next 40 or so minutes. The way I've structured this talk is I have an agenda. Yeah, okay, good, wonderful. So I start with understanding the traditional limitations of traditional CI/CD tools here, and then go about defining what cloud native technologies are and specifically what are the elements of cloud native technologies. Start with what are the key benefits of using something cloud native and obviously what are the challenges implementing that. And then I go about discussing some of the open source projects for cloud native world. Now, mind you, cloud native world is a big world. Every now and then there is a new tool, commercial or open source coming. So what I've done here is that I have picked the three most common tools that we use today. So one is Tecton Pipeline. I'll go into details of each one of them, what they are and what they're used for. Tecton Pipelines, Jenkins X, Argo CD. So these are the three most important ones. But of course, as I mentioned, there's a lot of tools out there. Okay, so let's start with what cloud native technologies are. We hear this term a lot, cloud native, cloud native. So I just want to nail down what specifically we are talking about. So this is the textbook definition of cloud native technologies, right? I've taken it actually from the Cloud Native Foundation, CNCF, and you can actually go through this definition, but there's a couple of things that I actually wanted to point out from here. And it talks about containers, service meshes, microservices, and you hear quite a lot of this term called loosely coupled systems that are resilient, manageable, and observable. What is this loosely coupled system? We'll talk about that also. Specifically, the cloud native technologies, we have these four key elements. So there's DevOps, there's continuous delivery, there are containers, and there are microservices. And we'll talk about each one of them in a little bit of details here. But I'll first touch upon what loosely coupled system is, or rather I should say what tightly coupled system is. When you change basically one part of the system, then the other part of the system gets affected. Loosely coupled systems do not have a very strict contact for communication with each other, right? So if you change one part, you actually don't really have to change another part. They actually have some kind of service contract as long as they communicate via the service contract, and you don't actually change the contract of communication. The component itself can change without really worrying about the rest of the system. So that's loosely coupled systems. Anyway, going back to cloud native stuff. Before we go into cloud native first, let's actually take a step back and look at the traditional CI/CD approach, what traditional CI/CD approach is. Typically, in a traditional CI/CD approach, we have a server, right? The servers has certain n number of often fixed build agents that are working 24/7. These agents could be Linux, Windows, or even in some cases Mac. And the server basically is kind of a controller which has service definitions for each one of these projects. And it continuously polls for source control. So each project has some configuration steps that you need to build. It is binded to a source control, particular repository in a source control. It'll poll for changes every time there's a change. It pulls, follows the steps that are defined in that project, assigns it to a build agent, builds an artifact, and possibly deploy it, test it, etc., etc. And each team basically contributes to this the source control, right? So there are a couple of examples of traditional CI/CD. Jenkins is the open source, probably by far the most common one, but you have TeamCity, Bamboo, Circle CI, Travis CI, and there's obviously a new tool pretty much coming every now and then. The challenge with these traditional approaches, first, they're not cloud native. They were built for an era where the artifacts were basically monolith services deployed on a virtual machine. Now, traditional CI/CD tools have evolved and many of them now support containers, etc. But these are add-ons as opposed to natively supporting them. Second, they're kind of hard to scale. When we are talking about basically large organizations where we are talking about like 1,000+ services, right? You have a lot of microservices, you have independence. You really can't have like 1,000 different projects. It's very hard for you to handle that. and you have 1,000 different projects with like repeated duplicated configurations, duplicated build steps, etc. On the other hand, even the build agents, right? You have fixed number of build agents. During your peak hours, your build agents get clocked because there's too much of workload on them. And during the off office hours, build agents basically are lying empty, but you're still paying for it. So scalability in these circumstances often become a challenge. Now, I should I should point out here that obviously the CI/CD space gets evolved. So some of these things have kind of been addressed. For example, modern CI/CD tools, they really don't believe in fixed build agents. They actually have the capability to have dynamic agents where you can switch on and switch off these agents. They tend to use like spot instances, which are preemptive instances for cost control. Um, so some of these issues have been addressed, but again, they were not designed for this purpose, right? So they started with a simple idea of having these monoliths and virtual machines, etc. And as time progresses by, new challenges come, they start addressing these ones. So the problem with these traditional infrastructure that we have found out is that there's too much of complexity, right? To automate everything, you have to do too much of effort. The microservices have a problem that their systems are very brittle. So they have many dependencies. It's difficult to debug, etc. So these systems are very hard to maintain at a scale. If you're doing a small project, of course, that's a whole different issue. But at a scale, they are very different and they're very error prone. Because imagine when you have 1,000 plus services, you have 1,000 plus projects with a lot of duplications and a lot of permission settings, you go nuts handling these configurations, right? So it's very error prone. Also, prior to the introduction of containers, you have an issue that your your production environment is different from your test environment. Ideally, a test environment and production environment should be the same, but in reality, they tend to be a little different because they're different environments. So you might have a reliability issues where something works on your machine, but when you deploy it to the production, it actually fails. Now, containers kind of solve these problems, and we'll talk about containers later on. But prior to containers, we do have reliability issues. We're also having single point of failure because when you're looking at controller, if your controller fails, then you're in trouble. Cost. When you have fixed number of build agents, these servers and agents are always on. That obviously increases your cost if you're running in cloud infra, and even if you're not using it, you're paying it. What you ideally want is some kind of serverless approach where you pay as you go resources, right? If your workload increases at peak hours, then you should be able to scale up, and if your workload is less, you should be able to scale down and not pay for the resources you don't use. So kind of a serverless CI/CD approach. Most of the traditional tools do not have that, although some of them have kind of incorporated that. I think I mentioned the build agents part where you can have dynamic build agents. So some of these issues have been addressed, but initially when they started, these issues were there. So that's a problem with traditional infrastructure. So now we go into cloud native. We have already defined what cloud native is. Let's actually dwell down a little more on it. Cloud native is an approach to build and run applications that can leverage the advantage of cloud computing model. Fantastic, simple definition. Now, I would also emphasize here that when you're talking about cloud native, you're not talking specifically about public clouds like AWS, GCP, or Azure, right? Cloud native is a broad term. You're talking about private clouds also, you're talking about on-prems also, because for a lot of organizations, they actually operate some sort of on-prem or hybrid. This is particularly true for financial organizations or even defense organizations where they have strict privacy requirements. So cloud native is a general term that encompasses the on-prem or hybrid approach also. So here are the numbers that I've taken from this website. The numbers keep changing, so these might be old, but they basically indicate kind of a scale at which we operate here. Okay, So we are talking about Netflix that has 600 plus services. Deployment is 100 times per week. Uber has 1,000. Holy shit. Deployment is also quite a lot. But the key idea behind these numbers is kind of the scale at which we are operating. Okay, so when we are operating at a scale, we really cannot, we need an approach that scales so fast, right? We can't go back in a traditional one service is occupying one build agent, and one project has one configuration, etc. At this scale, you really cannot have, you can't easily manage 1,000 different configurations with 1,000 different permission settings, etc., etc. So that's where the new approach is needed at that particular scale. So what are the characteristics of cloud native, right? To start with, applications are built and packed in containers. Now, earlier applications were monoliths that were packed in virtual machines. Now we are talking about containers. I'll go about details what containers are, although I believe containers is a fairly well established technology. But essentially, containers are some sort of miniaturized virtual machine where your service, your application is code is packed with the environment it runs on, as opposed to application code and environment separate. And the advantage that containers bring to the table is that when you have basically application packaged with environment, you don't really have surprises, right? It becomes one unit that you can take it and run it everywhere on your local machine, on some test environment, on some production environment. So it increases the reliability of the system, right? You don't really have surprises like, oh, it works on my machine, but it doesn't work on the production environment. So that's what containers really bring to the table. Services follow a pattern of what we call as immutable infrastructure. Okay, so once they are deployed, they are not modifiable. Pipelines are described in declarative languages. We'll see some examples, but essentially at scale, what we want is we don't want to give a prescriptive approach where we detail steps of what we need to do. We just tell them, this is what our code looks like. We kind of declare what we intend to do, and the CI/CD tool picks up from there. It's tightly integrated with platforms, for example, Kubernetes. We'll explain a little bit more about what Kubernetes is little later on, but essentially Kubernetes, or you could replace it with Mesosphere or other platforms, is essentially an operating system for your data that manages containers at scale. Then we are talking about dynamic agents and dynamic environments, right? At scale, we need agents that come and go, that can scale up and down. And to some extent, even the environments follow the same principle, right? We have concept of ephemeral environments. Ephemeral environments are basically short-lived environments. They can be used for a lot of uses, like for example, test cases. You spin up an environment, you do the testing, etc., etc. So that's ephemeral environment. Secondly, sometimes what you're doing is you're running certain machine learning batch workload, etc., where you set up an environment, you do some operation, and then you tear down the environment. You don't need that environment all the time. So you should be able to have these environments that can come and go. So they are ephemeral in nature. And because you're dealing with scale, what you really need is you need optimized resource utilization, right? You want optimized resource utilization to keep your cost down. Cost is a very important factor. And this is where kind of serverless CI/CD concepts come in, right? The whole idea of serverless is pay as you go. You only pay for the resources you use. So, so optimized resource utilization is a very important aspect to bring your cost down. So what are the benefits of cloud native CI/CD? We have talked about containers. We'll talk a little more little later on. But essentially with containers, what you have is you have reproducible and reusable aspect. Reproducible because your applications are packed with your environments, right? You really don't have surprises there. You can follow the exact same steps anywhere on the platform where container is supported, and you have the exact same artifact. Reusable, once you have a container, you can push that container in some kind of container registry, pull it down, so it's reusable across. You have dynamic orchestration. Dynamic orchestration is where you can change in an environment that you're operating at scale, things will fail, right? Things will fail. So you need the ability basically to repair, if your services are failed, you have a scheduler that detects, that does a health check. If something is failing, it can, recreate or redeploy the services. So you have this dynamic orchestration, and what it does for you is increase reliability. These were not a problem in the pre-cloud native world because your scale of operation was so small that it wasn't really an issue. But now we are operating at a scale here. Serverless resource utilization. Serverless model, pay as you go, reduced cost. We already talked about that. So how do we don't really want to incur a lot of costs in CI/CD. Conformant API. So when you have consistent APIs, what it gives you is portability, right? We are often what organizations run on, they are multi-cloud, they're hybrid, they run part of their application on-prem, part of them on cloud. So you really want some kind of portability, right? I don't want to be adapted to different environments all the time. But with benefits comes challenges, right? There are specific challenges of cloud native environment. First, we are now talking about container images instead of binaries, right? When you're talking about container images and binaries, you want containers to be a first class citizen with a lot of CI/CD tools not supporting containers directly. They can through plugins, but not directly, not a first class support. When we are talking about environments, we have many different kind of environments, and these environments, when we say different kind of environments, they one dimension is that you have the test environment, production environment, staging environment, etc. Other aspect is that you're operating on services that are globally distributed, right? When you're operating on services that are globally distributed, you have some data center operating in India, some data center operating in China, one data center operating in Europe, America, and within US also you have multiple zones. So you have a lot of different environments where you're deployed to, and your deployment strategy might not be just to deploy in every environment, right? You might want to have some kind of gradual rollouts, because if you have a bug or something that is bugging, then you don't want everybody to be affected. You want them to be deployed in one region. If it works, then it goes to another region, etc., etc. So you have a lot of environments to deal with. We have microservices instead of monoliths. Microservices sounds great, they're really a hot trend, but the problem with microservices is that they have many dependencies, because fundamentally microservices is very brittle. We have ephemeral environments. We have environments we talked about that are short-lived. These could be certain machine learning environments, these should be test environments, or even when you have something like you're running a serverless application, then your serverless containers can be ephemeral. For example, your billing and payment system often is serverless, because what happens is at the end of the month, customer does some billing, so you really don't want the billing and service to be running 24/7. You just run it once a month when the time comes, based on pay as you demand, etc. We have used the term containers a lot. So let's actually go about defining what these containers really are. Um, so essentially, containers is actually a binary and all its dependencies packed in a unit. Think of it as some kind of miniaturized virtual machine that basically shares an OS, and it runs as an isolated process, right? So there's no interference. And this is how typically the stack looks like. You have the hardware, you have the operating system, you have some kind of engine in which you have various containers, app 1, app 2, app 3. And containers are essentially layered structures. So you have a base image of pretty much any language, any library, any available, and you add on to it. So that's what your containers is. The key idea the container really brings is packing your environment with your application together as one unit, that you can port it anywhere, you can run it anywhere where its environment is supported. So it increases the reliability that way. But when you have containers that are running in scale, right, you're talking about thousands, or in some very large organization, it could go into millions. You need a mechanism of how I'm going to manage these containers at scale. And this is where Kubernetes comes in. Now, mind you, Kubernetes is just one example. It's by far the most common example, but not the only one. You have other systems like Mesospace, which I don't know anybody uses it at this point. But what is Kubernetes? It's essentially a platform for managing containers, right? So it handles common tasks like resource allocation and scheduling. You have resource allocation in the most optimal manner because you don't really want to have cost involved in it when you're running at scale. So it takes care of all the provision or deployment. You have issues like load balancing, health checks, traffic routing. Kubernetes has a scheduler basically that does health check on the containers, and if if the containers are failed, you can redeploy. You can scale based on workloads, auto scaling, scale up, scale down, health monitoring. We talked about it. It handles all that. Kubernetes essentially is a platform. Quoting someone said that Kubernetes is not an end goal, it's a great starting point, not an end goal in itself. Kubernetes is where your application will be running in containers. And the key idea of Kubernetes is that it abstracts away your underlying hardware, so computing, network, storage. Kubernetes has logical concepts, and and hardware are physical concepts. So you basically specify it on the logical level. For example, you have a concept of pods. Pods are basically where a certain set of containers would run together. For example, you need a service container to run alongside a database container. So you specify it in a pod. Pod is a logical structure. Virtual machine is a physical one. Kubernetes maps the logical one to the virtual machine. So that's what Kubernetes does. Kubernetes essentially is a descriptive system where you define what the state of your system is going to look like, and Kubernetes would try to ensure that your actual state matches what you've described. Kubernetes ecosystem is very big. You hear the term a lot. It follows infrastructure as a code. It uses horrible amount of YAML to specify. So you have basically tools like you have a CLI, kubectl, or kubectl, whatever you like to call it. You basically have a UI where you specify infrastructure as a code. Because you have it infrastructure as a code, you can actually version control, which gives you the ability to roll back to a particular version. It gives you auditing capacity. It gives you an insight on how your environments are evolving, takes care of optimized resource usage, and it has zero downtime with rolling updates because you know you're working in a dynamic environment. And we have already talked a little bit about health monitoring and health checks. So it has self-healing in case of failures, because when you're running at scale, things would fail. It actually takes care of that aspect also. It can scale up and scale down easily with one command or based on your load. You have the CLI tool kubectl. You can just apply the YAML file that does that. But when you have these Kubernetes, you have a lot of these configurations, you're still managing at scale, you need some kind of package manager. And that's what essentially Helm Charts brings to the table. Helm Charts is basically a package manager that extends Kubernetes. So what it does is it simplifies deploying and managing application, right? Because you have these templates that you can just instantiate. It allows user to define and install complex applications because there are similarities. You want to kind of abstract out these similarities. It has Kubernetes is a concept of resources, so it basically is a collection of pre-configured resources with templates that you can just instantiate the value and deploy it. Helm charts, you have different kind of charts within Helm charts. This Helm charts actually, Kubernetes is originally, I believe the word Kubernetes is Greek in origin, and I think it has something to do with navigation. I'm not sure. And Helm also is basically how you navigate the ship. So if you look at the symbol, you'll see in the movies that typically how you navigate the ship. So that's the historical aspect of Kubernetes and Helm. Anyway, so we're talking about pipelines. Why do we want to use containerized pipelines here? One of the things is that we're dealing with a lot of environments. So we need some kind of portability across environments. Okay. We want to deal with isolation and reproducibility. So we want to increase reliability. We don't want to have surprises like, okay, it works on my machine, but it doesn't work on another person's machine. So what containerized pipelines basically give you is they give you that isolation and reproducibility because you have exact steps that you're managing to build containers. Also, we are talking about scalability. Scalability is a very important aspect because remember, we are dealing with many services. Faster build and deploy times. We have the containers, we push them to the registry, we can deploy them easily. So the whole deployment process is fast and easy. And above all, when we are following an infrastructure as a code paradigm, then we have the huge advantage that we can actually version and roll back. This is an often underestimated advantage because versioning and rollbacks, gives you an insight on how your environment is basically evolving over time. And if something goes bad, you can just go back to the previous version and use it. So we have talked about container um, pipelines. Essentially, we are talking about this infrastructure as a code paradigm a lot, and GitOps comes from there. Now, what is GitOps? GitOps says that Git is the single source of truth. Now, you have specified everything as a code, right? You have your infrastructure, you have your pipelines, you have the configuration. All of them are basically code, often defined in YAML. So, what is your single source of truth? Your single source of truth is essentially going to be Git. So, or your version control system to be more specific. This is where you'll store all your configuration. And then what you have is every time you make a change, you have a pull request, the system will pull it, redeploy your, re-architect your config, re-architect your resources, etc., based on what you have described on your source code, re-architect your infrastructure. So GitOps, the textbook definition of GitOps is essentially a set of practices that leverage Git as a single source of truth, right? To manage and define the state of the infrastructure and application. The state of infrastructure and application is what you have described in your files. And all of that is a declarative configuration that you store in your version control because it's a version control. If your source code version control, you have the version control available. You can, go up and down. You can actually see all the patches. And then it does a continuous deployment for where basically based on pull request. So every time you have a branch, you have a pull request, it detects, it sees a change, redeploys it. GitOps is one of the founding principles for Argo CD that we're going to talk a little later on. But the thing I like about GitOps is basically is that pretty much everything that you need to know about it, it's there in one particular place. You don't really have to sit down because remember, you have many different environments, you have many different pipelines, etc. You don't want to be searching around for information. Okay. You also have observability and rollbacks because version control comes with an advantage of observability and rollback. So you can observe how your things are evolving and you can roll back at point of time. There are several benefits to GitOps. We kind of talked about it here and there. But there are tools that are implementing GitOps. Argo CD's founding principle is GitOps, but Jenkins, etc., they all often deal with GitOps. They're associated with Kubernetes, but the principles really can be applied everywhere. And that is, first and foremost, you have consistency, the single source of truth that is there in Git, right? This is where you can see that if there's a conflict, this is where you resolve the conflict. Once you have everything on your source control, you can collaborate with multiple teams. So that's great. You have versioning and auditing that comes with source control. So this is as far as GitOps. Now we are going to move into some specific projects that we are talking about, open source cloud native CI/CD projects. So let's start with Tecton project. Like, let's introduce what Tecton project. It's actually kind of confusing what Tecton is. So I'll try to clear the confusion here. But that's the logo for Tecton, and Tecton is an open source project, tecton.dev. And the textbook definition is that it's a powerful and flexible open source framework that provides shared and standard components for cloud native CI/CD. What does it mean? Well, what happens is that in a large organization, CI/CD is something very specific. So people want to implement their own CI/CD. What Tecton basically gives is it gives a starting point to do that. It's not so much of a finished CI/CD tool as much as it's a great starting point. It provides you with a standard set of components that you can glue together because imagine that you're building CI/CD, you have something like you need some mechanism to basically check your source control. You have some mechanism that you need to build on these containers. You have some mechanism that you need to to deploy it. While the specifics might be different, there are these common components that you're going to be using in every CI/CD tool. That is what Cloud Tecton gives you. It gives you the set of these common components that you can glue together to build your own CI/CD. And later on, projects like Jenkins X, which I'm going to talk later on, actually uses Tecton as its underlying base. So I'll cover more of Jenkins later on, but Jenkins X is an opinionated end-to-end finished product, whereas Tecton is essentially more of a framework. Another example of Tecton being used in industry is Rio. Rio is actually a closed source CI/CD tool used by Apple. So Apple based its entire CI/CD on Tecton. Okay, Rio is not available obviously outside Apple. It's a closed source proprietary product, but a company like Apple at its scale would like to have its own customized CI/CD tool. So they basically implement that using Tecton. It's a great starting point. The vision of Tecton. So there's four key visions of Tecton that you have. If you go to the website, they kind of describe it, but it's composable. You you need to have pipelines, sub pipelines that you can glue them together, so you can compose them to create a larger system. You need them to be declarative. Declarative is important because when you're dealing with things at scale, you don't want to have a prescriptive approach. I want to see this is my project. Tecton finds out this is what I want to do with it, and it knows how to deal with it. Reproducibility, you're talking about a lot of different environments, including effort environments. So you want reproducibility, and of course, we're talking about cloud native because this whole talk is about cloud native. So Tecton started as a I'll talk a little bit about history of Tecton, but Tecton essentially was one of the first cloud native CI/CD projects to support all the cloud native technologies as first class citizens. So what are the building blocks of Tecton? Like any CI/CD tool, you have a standard, like you need to have steps. I should be able to build these steps are combined into tasks, right? And common aspect of any CI/CD tool is a directed acyclic group of tasks because you want them for parallelization. So you have a pipeline, right? So you have different tasks, you have a builds task, then you have a testing task. The testing task might be testing the unit case that can be done in parallel to integration test. These are simple examples, but in real life, you have a lot of unit tests that you want to cluster them together. So, there could be a number of tasks for these unit tests. And, and pipeline basically forms a building block of an entire process. And these pipeline needs resources to run. So what are these resources? For example, source control is a resource. So whether you have a task or you have a pipeline, you need to bind them to resources. Resources are deliberately kept separate from pipeline because what you want is you want some kind of reusable pipeline, right? I have a pipeline, I can use it for multiple projects. So I don't really want to hard code the values to the pipeline itself. I want to bind these pipelines during runtime to values like, okay, what source control do I want to operate on? So these resources are that's why bound separately. And task also you can run them standalone because at the end of the day, task is essentially a pipeline with a single task, right? So task is the basic unit and pipeline is a combination of tasks. So these are the building blocks. The history part of it is pretty interesting. So there's another project called Knative, knative.dev, I think is the website, which basically talked about extending serverless application of CI/CD on Kubernetes. So the problem with serverless was very popular. You have AWS Lambda, GCP functions, etc., and etc. Serverless manages everything for you. But the problem with serverless was that serverless was very platform specific because the platform is managing everything. So it manages in a very specific manner. Portability was an issue. So Knative was a project that was built on Kubernetes to kind of what it had to do was it had to extend Kubernetes to support serverless, right? So instead of binding it to a particular platform, I bind it to Kubernetes, and because Kubernetes is widely available on all clouds, I can have my serverless running on Kubernetes. And Knative had three components. So it had build, eventing, and serving. Build was how you deploy it to containers. Eventing is the event framework because serverless operates on events. So you have an event framework, you have some trigger, you have some channels, and then you have serving. Serving was how you route traffic because you know basically have events that are coming, then events are being routed in traffic to different functions or containers. Functions and containers in Knative world is interchangeably used. And what was found was that people and the design of Knative was basically these three components are loosely coupled, right? Because you can swap serving and you can just use eventing, etc. Or you want to modify, have your own version of serving. So deliberately, these three events were split separate. But when you have that eventing framework or build framework, etc., separate, what happened was that people started using build specifically as a CI/CD because cloud native was new, and at that time there wasn't much of CI/CD tools for cloud native world, and build became immensely popular. So it was decided that because build is so much popular, we'll take the build out of Knative and we'll spin it in its own project called Tekton. So that is how Tekton actually was formed. So that's the history. I think it happened in version 0.8, if I'm correct, of Knative. So this is an example of Tekton pipeline, right? You have some metadata, you have some tasks, you have some parameters, and you have these steps. Define run after because you have to specify the dependency because it's a directed acyclic graph of test. Everything is specified in YAML. Anyhow, moving on. So we move on to another project called Jenkins X. Now, Jenkins X should not be confused with Jenkins, and there are two different projects. So Jenkins X, the history of Jenkins X is that it was introduced by this guy James, who's the creator of Groovy, Apache, Camel, etc. And Jenkins X is a completely different code base from Jenkins. So it was designed ground up to be a cloud native Kubernetes native. The common aspect, it's kind of a spiritual port of Jenkins for the cloud native world. So Jenkins, as we understand, is basically a general purpose automation server which can be extended by plugin architecture. So it's kind of an open source. So Jenkins X embodied the same philosophy that what we want is we want an open source general purpose engine that can do anything and everything and can be extended via plugins. Great, but has to be cloud native. It supports all the cloud native technologies. So it was a spiritual port, but the code base of Jenkins X is completely different from Jenkins. So you really can't migrate from Jenkins to Jenkins X. None of the plugins would work. And in fact, Jenkins X uses Tekton as its base. So Tekton is essentially a framework, and Jenkins X is a finished product that uses that framework. So it's an opinionated way of doing it. But like I mentioned, it's supposed to be an extendable automation server that can be configured to do anything and just about automate any task. And it's based on a plugin based architecture. So you can be a CI server, CD hub, etc., etc. Like any other CI CD tool, Jenkins X, the way it works is like it has CLI tools. It supports all these technologies, Docker, Kubernetes, controller, etc., etc., and supports first start, support for Helm charts, etc. And Jenkins X is supported by several cloud providers. You would imagine Google Cloud Engine, Red Hat, Amazon, Azure, IBM. Now, Red Hat and IBM is the same thing, but back then, when Jenkins X came, it was actually kind of different. And Oracle Cloud. And also, it supports Minikube and Minishift, which is basically Kubernetes, local Kubernetes for your laptop or for your machine. So that's the website for Jenkins X. They have basically a web UI, which is actually, frankly, quite horrible in my opinion. And they have a command line tool, and you can do all these things like create cluster, etc., etc. What are the benefits and drawbacks of Jenkins? Okay, so benefits. It's a cloud native solution for Kubernetes cluster, or for that matter, cloud native technologies in general, because it was designed ground up to be for cloud native. There's an automation of CD pipeline that allows a shift left paradigm. For those who don't know what shift left is, shift left essentially embodies a principle of agile computing where you want to basically detect mistakes as early as possible. So shift left, find it as soon as possible. Left is where your pipeline starts, right? Right is where your end pipeline ends. So shift left means basically as early as possible in your pipelines. And there are some ready-to-go pipelines, so people can move fast with ready-to-go pipelines. But the drawback is that it's while it is a spiritual port of Jenkins, it really has nothing to do with Jenkins other than the name. So you really can't migrate pipelines from old platform to new platform. None of the plugins would work. And UI is kind of shitty, but I should point out here that because the nature of the product is that it's extensible by plugins, you can actually have a plugin that can the UI come up with a new UI. Often what people find, and this is probably true for both Jenkins and Jenkins X's, that they have their own UI and they use Jenkins on the back. So you actually don't really interact with the Jenkins UI directly. You might be using some custom UI. And Jenkins is an automated server that is kind of abstracting that out. Now I'm going to introduce Argo CD, which is another popular project. Now Argo is mostly a GitOps based deployment tool, not so much of CD. So Argo is used often in conjunction with the CI tool because it doesn't really handle the aspects of CI that well. So the definition, it's an open source declarative CD tool for Kubernetes that follows the GitOps. GitOps was one of the founding principles of Argo CD. And pretty much in line with GitOps principle, you have a desired application state that you have in your source control in your Git repository, and Argo would try to match it as much as possible. So Argo CD essentially ensures that the deployment application works the same way as what your desired state is. And general purpose CD, so designed to automate pretty much anything and everything. Okay. So the features of Argo CD, you have gate, you have pull based, it handles the cluster, it syncs up, it has a web and UI CLI, you would expect that. Because it's Kubernetes, it handles multi-cluster and multi-tenancy, very important. Because it's GitOps based, you have the advantage of version control, so you can roll back and roll forward. It takes care of all the synchronization and health status checks for you. And because it's an open source project, you would extensively be customizable. Okay, towards the end, what I want to do is I want to basically kind of compare the different cloud native tools. I'll just talk about these three projects because there are so many projects that if I start talking about all the projects, I'll run out of time. Okay, so let's start with Tecton. We have talked about Tecton, but the most important thing that you have to remember about Tecton is think of Tecton as a framework, not as a final tool, right? So it's as a framework of loosely coupled components that you can glue together to build your own CI/CD pipeline. It's a great starting point as opposed to a finished product. You can use it for CI/CD as it is, but it's pretty shitty if you want to do that. Jenkins X, on the other hand, uses Tecton, but is otherwise an end-to-end CI/CD platform, right? Which is a spiritual port of Jenkins, but the code base is completely different, tailored for Kubernetes or essentially supporting cloud native technologies as a first-class citizen. And Argo CD is essentially a deployment, uses GitOps as its founding principle. I have barely a minute remaining, but I'm open to questions if any. I should check the
Cool.
team.
Thanks. Nikhil. Okay. Not sure. Okay. Can you hear me?
Yes,
Looks
I
like
can
this.
hear you. Do we have any questions?
Yeah. Are there any questions from folks? Yeah. So why don't you just maybe come over here?
Or you can repeat the question. That's okay too.
That's fine.
Okay. So thanks for that introduction, actually. Thanks for the introduction of all those three tools and the comparison of the three. That was really helpful. I have questions specifically about Tecton in general. So you mentioned Tecton is a framework, and assuming that we'll have to create that end-to-end finished product like Jenkins X if we are using Tecton,
Yeah.
then in that case, I'm assuming we'll have to have create the agents also, uh, uh, which will have a container, running container into container kind of a facility, right? So since it is running into K8s environment, we'll have to create an agent which can essentially in today's world, actually, we need to run container within a container thingy as well.
Yeah.
So in your experience, how difficult it has been? I'm not really sure. That is one question. If you can answer.
Yeah, so it
what
provides
could be around it.
support for that because this is what it builds. Essentially, this is what it brings to the table. See, the thing is
Okay.
that in the absence of tectons, you have to do it yourself, right? So
Okay.
that's what the tecton does. Essentially, it does the container in a container. It can even do a, I think you can even build a container even otherwise on a VM. It gives you the flexibility to do it. The thing about tecton is that tecton does not give you a predefined way of doing things, because it's not opinionated, it's an open source. So it has components for
Okay.
most common tasks that you can tailor it to your needs. So you can have a container to container, but not everything becomes container to container, because remember, if you're building Mac OS, then you can't do a container to container. If you're building apps,
Exactly.
right?
Exactly.
So you don't want a framework that pigeonholes you in something specific. What you want is
Correct.
you want to have choices that depending on your projects, you write your logic and say, for this project, do this, for this project, do this. That is what Tecton is.
Okay. Okay. Cool. Thanks. If I may, I have another question as well,
Yes.
if we have time. Okay. So since these are cloud native, sorry, I'm just, a beginner into this particular space anyway, into DevOps world. But another question that I had was, if we had to suppose create a CI/CD solution for a particular enterprise, then isolation of a workload is one of the questions. So when we have these agents and everything running, I think I'm assuming that we'll have to create another K8s cluster only for the agents, and then the deployment of this would basically happen into another K8s cluster of their respective environment. Is that the right understanding?
No, we don't really need another cluster. You can run the entire CI/CD in one cluster. Why do you need a separate cluster? Deployment, yes, when you're deploying it,
Deployment is what I'm talking.
yeah. You have a choice, because at the end of the day, deployment, you specify the cluster. You can specify the same cluster, you can specify a different cluster. It's up to
Then
you.
isolation,
But you
would
anyway
it have?
because clusters has an isolation, right? When you're deploying a container. So container itself is isolated from the rest of the cluster. So you get that built isolation anyway. Container by definition is isolated, right? So if you are deploying a container to any cluster, you have isolation right there.
Got it. Okay, cool. Thank you.
Thank you.
Thanks for answering those questions.
Yeah.
I think we have one more question.
Yes, sir.
Yeah, this is Sri Krishna here. So I have a question about this GitHubs and this Agro CD, right? Are there any observability related tools around to see how things are going, right? In case you have a large setup to see how many commits have happened, who has done what, that type of stuff.
I mean, that's more of a Git question than actually an Argo CD question, right? Because commits are happening to a source control. So what you're really asking is, how can I have a visibility on my source control? Because Git is just pulling from there, right?
Yeah,
So,
that is correct.
yeah, so you do have tools for source control. You have like whole lot of these. I think I can name some of them, probably Git Tower, etc. But you have like Git is itself has such a huge command line. You can do all that from Git itself. So you already have Git itself available. Plus you have commercial tools for all these visualizations and reporting, etc. that you're talking about.
Okay.
Right? You can do a Git log, or I don't know, Git filter by user, etc., etc.
Yeah, that's command.
Cool. I think we've got all the questions. So again, I want to thank you, Nikhil, for waking up in the middle of the night to do this for us. Appreciate that. And take care. Talk to you soon. Bye bye.
Thank you, Naresh.
Thanks,
Thank you.
everyone. Bye bye.